Right, obviously we are continuing with our discussion on geometric sequences and series, and if the constant ratio is 1/5 and the first term is 2000, we determine the general term T7, etc. So let's get started. How do we find the general term of a geometric series? How? We stated that and we continue with that. Right, to find the general term, we proceed as follows. So we're going to look at 1A. 1A. Right, the general term formula for geometric series, this is the term formula, AR to the power n minus 1. Right, what is the first term in the question? We're told that the first term is what? Is 2000. We're told that the constant ratio is 1/5, so that we put here 2000. And the constant ratio is 1/5 to the power n minus 1. And this is the answer. This is the answer. This is the general term. Next question. If you look at 1B. 1B. T7. So you know that Tn is exactly 2000 into 1/5 to the n minus 1. So that when you have T7 is equal to 2000 into 1/5 to the power 7 minus 1. Right, and so if you have this now, you're going to use a calculator to simplify this. And the simplified answer using calculator is exactly 16 out of 125. And that gives us the 7th term of this series, okay? Because if you got this question here, they said need to find the general term. General means that it must be T sub n. It must be a function of n. It must depend on n. And so T7 we have just found now. Which term of the series will have a value of 16 out of 15,625. So we're looking at 1C now. We're looking at 1C. Right, so now if our Tn, we already know that our Tn is 2000 into 1/5 to the power n minus 1, and we're then saying we want which term will be called, the term is 16 divided by 15,000. 625 equals to 2000 into 1/5 to the power n minus 1. All right, so having this in mind, what do we then do here? We want to solve for n. So to do this, we proceed as follows. Right, so how do we proceed to solve these? Right, we divide both left and right by 2000, so that you'd have here 16 out of 15,625. 1 divided by this, which is 1 divided by, and then you have 1C, and then you divide these here. Okay, if you simplify these using a calculator, this becomes 1 divided by 5 to the power 9, which is 1 divided by 5 to the n minus 1. Right, so the bases are the same, which means 9 is n minus 1, which means n equals 10. That becomes the answer. Because now the question was, which term of the series will have a value of these? Which term? So if they say which term, we've already seen that it is the 10th term of the series. It's term number 10 of the series. Right, next question. Good question, this part 2. Consider the geometric series with where Okay, there is a geometric series. So it's geometric, meaning it has a constant ratio. Now, something extremely important is to note that we have the infinite series, the sum to infinity of Tn equals 27 here. Right, and S3 is 26. The S3 means the sum of the first three terms of the series is 26. Calculate the value of the constant ratio R of this series. So we need the value of the constant ratio. So we need R. We're looking for R. The value of the constant ratio, we're looking for R. So 2. Right. Right. See, I'm getting a report here. Let me see where that is going to land. Okay, so if you multiply out here, is 27 minus 27 R cubed equals 26. You still with me, Lerato?
Yes.
Okay, thank you. Right, so you have 27. You have 27 minus 27 R cubed. You see, I'm getting a report of audio issues here. I'm wondering on the system. Right, so if you have this, then it means therefore you have 27 R cubed equals, right, you transpose this one, so it becomes 27, which is 27 minus 26. equals 1. 1 out of 27. 1 out of 27. So if you take the cube root, this is the cube root. The cube root becomes exactly 1/3. And that means, therefore, that R is 1/3. Okay, so that's sort of the answer to this question. Right, so we sorted. This is the constant ratio. Right, so let's look at just another question. Let's look at another question on this geometric series. Right, it's question 3, this one. For which values of x will the following geometric series converge? And then we have part A, which is 1 plus into 2x plus 1 plus 2x plus 1. You square this. Part B, 2 minus x plus 2 minus x. You square it. Okay, let's see. Yeah, squared plus 2 minus x right, plus 2 minus x, 2 minus x cubed, and so on. Now the third one is the sigma notation symbol, which is I equals 0. 4 into 3 minus x. So solution which is 3a, for which values of x will this series converge? So in 3a, we're looking at the series, that one. So in the exam, they can give you 1 plus 2x plus 1. They can give you like 2x plus 1 squared and so on. And so first we must find the... Okay, we have already been told that it is a geometric series. Because the geometric series, you need to find the constant ratio. So now you need to find the constant ratio. So the constant ratio is T sub is actually R, which is the second term over the first term. This over 1. So now with this, which values of x will the following geometric series converge? So the first term is 1. One divided by 1 minus 2x minus 1, which is minus 1 over 2x. Okay, so we have the sum to infinity, which is minus 1 over 2x. So, which is 2 minus x. So now, which means the constant ratio here is up. You see? All right, so just note that here you need to find the values of x for each to converge. But yeah, that is the sum to infinity, but it's not exactly what the examiner wants here. They want the values of x for each to converge. So now for convergence, you'd need therefore that the constant ratio be smaller than 1 in modulus terms, which means that you need 2x plus 1 to be smaller than 1. So 3a, which means minus 1 less than 2x plus 1. You subtract 1 throughout. 1 minus 1 is a 0. Right, you sort of divide by 2, or you multiply by 1/2. So because you want to remove this one, you multiply by 1/2 because it's only multiplication by 1/2 that's gonna remove the 2, giving you minus 1 less than 0. Okay, so this is the answer. This is the answer. So yeah, minus 1 less than x less than 0. Okay, you're looking at 3b. So square 2 minus x. So which means therefore that the common ratio is t2 over t1, 2 minus x divided by 2 minus x squared, divided by 2 minus x, which is 2 minus x. Which means here we require these for convergence. Right, so what do we then have here? Okay, this is true for convergence. Right. So which means here we need the absolute value of the constant ratio to be smaller than 1, which means that we need this here. R is called the constant ratio. Right, so now at this point, you'd need minus 1 less than this. So you subtract 2 from each side. Subtracting 2 is this. Subtracting 2 is that. So 3b. So which means that is minus 3 less than x less than minus 1. Right, so at this point you need to multiply through by negative because you need x, so you multiply this one. So you have this. So hence 1 is smaller than x, smaller than 3 is the interval of values of x for which the geometric series converges. Okay, so that's what we have. And then we look at 3C. Right, you have the summation to infinity. This one. Okay, so this one is in sigma notation. 3C. Okay, the way you're going to practice this is to repeat these questions, is to take them down in your notebook, and then you see if you can do them again and get the same answers. You know, you watch the videos again, and then you make sure that you can be able to do this again, and that is how you can learn this. Okay, obviously, this is called sigma, right? This big symbol is called sigma. And then now you have small one. This is also sigma. But this other sigma is a small symbol. Right, so being a small symbol is lowercase or lowercase or small letter. Right, so but this one is the uppercase. Right, it's called the uppercase. Okay, now I got 0. And then now if you put 0 here, it's going to be 1. Right, just do something snappy. Snappy, okay. So when I is 0, this becomes a 1, but if you put a 1, two. Yeah, put 1, 2, and so on. Constant ratio. T2 over T1, T2. So you have this. And then 3B. And then you have, okay, this is the constant ratio, 3 minus x. So yeah, for base of x, for it to converge would be 3 minus x smaller than 1, minus 1 less than this. Okay, this is called this symbol is called the absolute value. Just to mention this. Absolute value of x. That is what this is. Okay, so in mathematics, it's just a law, a property. A property of these, that if this is smaller than 1, for example, yeah, then you have this. So these are the same thing. So if this is smaller than anything, then this is true. Okay, right. In particular, smaller than 1, just an example here. Okay, so we have this. So now what you do here, you need to subtract 3. So minus 1 minus 3 is minus 4. 3 minus 3, 0. But that leaves us with minus x. 1 minus 3, minus 2. Okay, you multiply through by minus. Okay, you see here, we multiplied through by minus 1, and the inequality changed direction. So it was less and then became greater. Became greater than, so even here, I multiplied through by minus. So 3b. So 2 less than 4. Hence, 2 less than x less than 4 is the interval. Is the interval of values of x right, for which the geometric series summation of 4 into 3 minus x I equals 0. Yeah, for which this geometric series converges. Okay, what does it mean to converge? Right. What does convergence mean? Convergence? What is this? Well, convergence means convergence of a geometric series means that the sum to infinity exists and is a finite number. Finite number. That is the sum to infinity, which we define like this. Its existence means that this is a finite number. Like so. Okay, we shall look at more examples on this. Right, can I just conclude our discussion now? We shall return again later. Just take note of these examples we have done now, and I'm going to pause the video in the next couple of a minute or so, and then we shall continue a little bit afterwards. Okay.
Okay, sir.
Okay, fine. Thanks. Let me upload the video, send you the link, and then we'll talk on WhatsApp. Yeah. Okay, thanks. Yeah, okay. Yeah, the video is always perfect in recording because the network might be bad sometimes. You know, you never know. The strength might be down, might be low of the network. Okay, thanks. And let's chat on WhatsApp.